For over 70 years, the aircraft carrier has been the ultimate symbol of American global power projection. A mobile, sovereign territory capable of delivering overwhelming force to any coastline on Earth. But for decades, the backbone of this force, the mighty Nimitz class, has been a product of Cold War engineering. Now, a new king of the seas has arrived, a $13 billion technological marvel so advanced it redefines naval warfare itself. This is not just an upgrade, this is a revolution. This is the Gerald R. Ford class, the largest, most expensive, and most deadly warship ever constructed. In this video, we will dive deep into its decks, explore its cutting-edge systems, and uncover why, despite its astronomical cost and teething problems, it represents a quantum leap that secures American naval dominance for the next half-century. To understand the Ford, we must first appreciate the titan it was built to replace, the Nimitz class. For nearly 50 years, 10 Nimitz carriers have been the unchallenged masters of the ocean. At 97,000 tons, over 1,000 feet long, and powered by twin nuclear reactors, they were a monumental achievement. But their design was frozen in the 1960s. Their steam catapults, mechanical arresting wires, and analog systems required enormous crews and were reaching their physical limits. The U.S. Navy needed a carrier built for the 21st century, one that could handle more sorties, integrate drones, and harness digital technology. Thus, the CVN-21 program, Carrier Vessel Nuclear 21st Century, was born, later christened the Gerald R. Ford class in honor of the 38th president. The numbers alone are staggering. At 1,106 feet, it's longer than 3 football fields. Its 100,000-plus ton displacement is greater than that of most navies' entire surface fleets. But as we'll see, its true power isn't in its size, but in what it can do with it. The most radical change on the Ford is found on its flight deck. Gone is the familiar puff of steam. Replacing the classic steam catapult is a system that seems like science fiction, the Electromagnetic Aircraft Launch System, or EMALS. Instead of using superheated steam stored in massive tanks, EMALS uses powerful electromagnets on a linear induction motor to catapult aircraft. Think of it like a super-powered, incredibly precise railgun for planes. The advantages are profound. Steam catapults deliver a brutal, jarring kick to an airframe, which causes wear and tear. EMALS provides a smoother, controllable acceleration that is gentler on aircraft and can be perfectly tuned for everything from a heavy growler electronic warfare jet to a lightweight drone. This flexibility is key for the future. Paired with this is the Advanced Arresting Gear, AAG, which uses turbo-electric motors and water twisters to recover aircraft instead of old hydraulic systems. Together, they are the engine of the Ford's primary advantage, a massive 33% increase in sortie generation, capable of launching over 160 missions a day, and surging to a staggering 270 in a high-threat scenario. While the flight deck is the fist, the island is the brain. The Ford's island is smaller, repositioned further aft, and far more advanced. It's dominated by the dual-band radar, DBR system, primarily the SPY-3 and SPY-4 arrays. The Nimitz required a whole forest of different radars for air search, surface search, and fire control. The Ford consolidates Soyuzhishia, all of these, into one integrated system. This reduces clutter, maintenance, and most importantly, its radar cross-section, making the Ford a slightly harder target to spot. All of this demands immense power. The Ford's new A1B nuclear reactors, while smaller than the Nimitz's, are far more efficient. They generate an estimated triple the electrical power, over 10 times 0 megawatts. This is enough to power a small city, and crucially, provides a massive power surplus for future weapons like railguns and high-energy laser defenses, which are already in testing. This automation extends below decks. Automated material handling systems move ordnance with robotic carts, and overall systems management requires hundreds fewer sailors, reducing lifetime costs dramatically. However, no leap forward comes without stumbling. The Ford's journey has been marred by significant technical challenges and cost overruns, drawing sharp criticism from Congress. In its early years, the new systems proved problematic. The advanced weapons elevators, designed to be faster and require fewer crew, were plagued with software and design flaws, with some taking years to become fully operational. The crown jewel, EMALS, suffered from reliability issues. Early reports indicated a failure rate far short of requirements, meaning the system would break down after a few hundred launches instead of the required several thousand. Critics argued the Navy was deploying an unproven, bleeding-edge technology on its most important asset. The Navy and contractors like Huntington Ingalls and General Atomics have been working tirelessly to rectify these issues. The argument has always been that while the upfront cost and pain are high, the long-term savings and capabilities will justify the investment. This is a ship built not just for today, but for 2070. So, is the Ford truly unsinkable, as some claim? In a conventional sense, its size and extensive compartmentalization make it incredibly resilient to damage. It would likely take a concentrated barrage of the world's most powerful anti-ship missiles, or a tactical nuclear weapon, to put one on the bottom of the ocean. But in modern strategy, sinking a carrier isn't the only goal. Mission killing it, making its flight deck inoperable, is often enough. Adversaries like China have invested heavily in long-range ballistic missiles like the DF-21D, designed specifically to threaten carriers. The Ford's answer is, not just armor, but superior technology, launching more aircraft from further away to destroy threats before they ever get close. It's the centerpiece of a networked fleet. With 5 ships planned, Ford, Kennedy, Enterprise, Miller, and an unnamed hull, the class will eventually form a new, more capable backbone. They are designed to operate with unmanned loyal wingman drones, directed energy weapons, and systems we haven't even imagined yet. The USS Gerald R. Ford is more than a warship. It is a statement that the United States is willing to invest unprecedented resources to maintain its command of the seas. It is a floating testament to American engineering, ambition, and military doctrine. It has faced and overcome severe challenges, and more undoubtedly lie ahead. But with each successful deployment, it proves that the future of naval aviation is here. It is faster, more powerful, more efficient, and more automated than anything that has come before it. It is, without a doubt, the new apex predator of the world's oceans. What do you think? Is the Ford class worth its massive price tag, or is it a floating monument to military excess? What feature, emails, its nuclear reactors, its reduced crew, impressed you the most? Let me know your thoughts in the comments below. If you enjoyed this deep dive into modern naval engineering, make sure to hit the like button, subscribe to the channel, and ring that notification bell so you don't miss our next episode. Thanks for watching, and we'll see you in the next video.